My name is Dr. Kerry Rowe. I'm a Canada Research Chair in Geotechnical and Geoenvironmental Engineering here at Queen's. And my research focuses on containment and protection of the environment from contaminants. Examples of that include the design of landfills and the protection of the environment from contaminants escaping from mining applications. Landfills have a checkered history. We used to call them landfills, we used to call them the town dump, and in fact that was probably an appropriate terminology. In the same hole in the ground you'd find rotten tomatoes, you'd find old machinery, you would find barrels, and in fact often barrels of quite toxic chemicals from manufacturing processes, from dry cleaning processes, and everything went in together. Now the material that was around that pit, if it was for sand or gravel, is by its nature permeable, and so water can flow through it very quickly. And so once you cover it all up and then water starts flowing through it, it starts to leach out the contaminants. The other issue is that when we dispose of organic waste, as it biodegrades, it produces gases. And two of those gases are carbon dioxide and methane. Both we now know are greenhouse gases, but more importantly, from a health and safety perspective in the short term, is methane is explosive. So those are the two prime concerns that have been raised about the old dump and why we now focus on building modern landfills. So a lot of my research has been developing leachate collection systems that would withstand these processes. We can't stop them happening. Nature is nature. But what we can do is minimize the effect and to the extent we can get the bacteria to work for us instead of against us. The graduate students and research collaborators assisted in developing a very sophisticated model that would allow us to predict what happened as leachate went through, as the bacteria grew, so that we could work out how long these systems would last if you adopted a certain design. We developed recommendations that are now part of regulations and are used by many people around the world in designing their leachate collection system. So that deals with part of the issue. That is trying to reduce the driving force for the leachate to escape. The next part is the resistance. If you don't have the natural clay, what do you do? And the answer became composite liners. So we use a geomembrane and a clay liner. If we use them together, we take the advantages of one and the advantages of other to complement the disadvantages of each. And in the 1990s, the development of what's called a geosynthetic clay liner, GCL, began in Germany and soon spread to Canada and North America and other parts of the world. So a lot of our research has been related to understanding, firstly, the hydraulic characteristics, secondly, the diffusive characteristics of the GCL, and thirdly, the transmissivity of the interface of a geomembrane with the GCL. So that raises the question, of course, how long will these things last? And so for more than 20 years now, we've been exploring that particular question. How long will they last? We have to use what we call accelerated aging techniques to allow us to understand what's going to happen with time. The research is big picture research. It's dealing with large periods of time and field scale down to laboratory to theoretical modelling. One of the reasons we built our Queen's University Environmental Line Test Site was to study that, where we could go and study it at any time of day, at any time of year, over many years, to see if there was a change in what happened with time. If I had to give a quick summary of what I do, it is basically, like all scientists, to understand the fundamentals of what is happening. To understand what we don't understand today so we understand tomorrow. But what is a particular focus of mine is I pick my problems to be ones where I can see an important engineering application that will benefit society. The graduate students play an absolutely crucial role in the research that I'm doing. Not only are they incredibly important to getting the research done, but after they leave here, they either become academics or go into industry. And they actually take this state-of-the-art knowledge to wherever they're going and help actually spread the word and get people to pay attention to what is going on. On a personal level, I think the most significant thing to me, having been in this for 40 years, is the opportunity to really help protect the environment for today, tomorrow, and in particular for the generations of the future.